Let's quickly do a review of what we did last time on our work. We were talking purely about classical mechanics. We reviewed the overview of classical mechanics, and we were able to discuss that classical mechanics is actually a branch of physics that deals with motion of objects and the forces acting on them to cause that motion. We discussed classical physics, classical mechanics, which is a branch of physics that deals with the motion of objects and forces acting on them. We also discussed fundamental concepts of classical mechanics. We discussed fundamental concepts of classical mechanics. Jason, are you there? I want you to mention those 3 fundamental concepts of classical mechanics. Mention the 3 fundamental concepts of classical mechanics. Yes, I want your hands up. I want your hands up. That's Adasa. Adasa, go on. Go on, Adasa. You have the floor.
Yes. Good morning, sir.
Good morning, my dear. How are you?
Fine, thank you, sir.
Go ahead and answer my question.
Okay, number 1, dynamics.
Dynamics, yes.
Number 2, kinematics. Kinematics, number 2, and statics, number 3.
Not kinetic. It's not. Not kinetic.
Kinematics.
Correct, better. Yes.
Statics.
Statics. Yeah, you're right. Right. You're right. You are correct. God bless you. You're very correct. God bless you. You can lower your hand, Adasa. Well, Adasa was able to tell us the fundamental concepts of classical mechanics. She mentioned kinematics, she mentioned dynamics, and she mentioned statics. She mentioned those 3. Now, Cynthia, can you please describe kinematics? Cynthia, can you please describe kinematics? Cynthia, can you please describe kinematics? Cynthia, can you please describe kinematics?
So I was a new student. I'm a new student.
And this I just joined the class. You're joining the class? Hello, Cynthia.
Yes, sir.
That's all right. Success. Please go ahead and answer that question. Success. I'm waiting. Success. I'm waiting. Success. I'm waiting. Success, I'm waiting. Okay, if success is not talking, she's not participating in the classroom, I'll be doing my scoring also according to participation in the classroom participation. I'm going to do that. I'm going to be marking my attendance henceforth. If you are regular in the classroom, you get better scores for that. And if you're not regular, you should be known that you're not regular in the classroom. So I'll be marking my attendance henceforth. I'm sorry. I'm marking my attendance henceforth, and I'll mark my attendance I'm supposed to be having 13 students for this class for general physics. I'm supposed to be having 13 students, but right now I'm only having how many? 1, 2, 3, 4, 5, 6. Only 6 students are joining this morning, and I'm going to take attendance for only those 6 students who are here. I'm going to take attendance for them. Instead of out of 13, I'm having only 6. So, Victor, you're welcome on board. And Desiree, good morning. How are you? Well, let anybody who want to describe kinematics, let the person answer. Chicken on, who's answering? Who's answering my question? Describe kinematics.
Good morning, sir.
Morning, chicken on. Describe kinematics.
Sir, it's a branch of science. Good morning, sir.
Good morning, how are you?
It's chicken.
Chicken, how are you?
Fine, sir. I'm fine, sir.
Good.
So it's like a branch of science that deals with the study of motion.
The branch of science that deals with the study of motion.
Sir?
You have not completed that?
Yes, sir. That is what I think it is.
Well, you have tried, but I described it very well and concisely in the class last lesson. That was last week. But you are yet to say what I want to hear. There's a phrase that is missing.
Sir.
And the phrase that is missing. Desiree.
Good morning, sir.
Good morning, my dear. How are you?
Sir, it's the study of motion and the force that acts on them.
And what? Desiree, go ahead.
And the force acting on them.
Hey, you are describing something else. You are describing something. Success. Go ahead. Success, go ahead and answer the question. Success.
Okay, good morning, sir.
Good morning, how are you?
Good morning, sir. Can you hear me? Good morning, sir.
Good morning, how are you?
I'm fine, sir. I'm fine.
Good to know.
So, kinematics describes the motion of objects.
That's good, that's correct. Yes, go ahead.
Hello, sir.
I said, that's correct. Go ahead.
Yes, it describes the motion of the objects.
Yeah.
Okay, without considering forces or masses.
Without considering what? Without considering what?
Forces or masses. It describes forces or masses.
Who again is trying to answer the question? Okay. Adasa. Adasa.
Yes, sir.
Yes, I'm listening.
Okay, kinematics, describes the motion of objects without considering the force acting upon it.
God bless you, you got it right. Without considering the forces or the force of forces acting on it. It only considers or describes the motion. It does
Thank you, sir.
it does not consider what causes that motion. That is kinematics. Earlier, Desiree was describing something else, which I'm still going to ask you. So that's right. Lower your hands. You can lower your hands now. You can lower your hands now. Can we consider dynamics now? Let Desiree now describe dynamics. Desiree, describe dynamics. Desiree.
Good morning, sir.
Good morning, describe dynamics.
So dynamics are forces in equilibrium. They study forces in equilibrium.
My dear, you have
Sorry, Ja. They describe forces.
That's a dynamics.
Describe forces in equilibrium.
My dear, you are not saying the right thing. Not correct. That's not correct. That's a total deviation. Okay, who's ready to answer the question correctly? Emmanuel? Adasa? Go ahead.
Yes. Okay. Dynamics describes a motion and the forces causing the motion.
God bless you. That's very correct. Dynamics describes the motion and forces causing or acting on that object for it to move. That's dynamics. I don't know. Something's happening. This area has written something wrong. I don't know what this is. Why this is always giving the wrong definition to those concepts. Now to statics. Make case now describe statics. Make
Yes, sir.
describe statics.
Sir, can you
Describe statics.
sir?
Describe statics. You're not saying anything. I love you. Jason.
Yes, sir.
Jason.
Sir.
Jason. It's your turn now. Describe statics.
Yes, sir. Static is the force that acts on an object.
Say it again.
Static is the force that acts on an object.
That do what?
Is the force that acts on an object.
Is the force that acts on an object. That's not correct. That's not right. That's not right. Desiree, yes. You want to try again? Go ahead. Desiree, go ahead.
Statics is the study of forces in equilibrium.
Say it again. Say it again.
I said statics is the study of forces in equilibrium.
Is the forces in equilibrium? No, that's not correct. Say it again. You
Is
have
this of forces?
take it again. Relax. Take it again.
And statics is of forces.
Is what? Statics is what?
The study of forces
Good.
in equilibrium.
The
Describe the study of forces in
The
equilibrium.
study of forces. Say it again. Take it again. The study of forces. Yes. Take it again.
In equilibrium.
No, you are saying breaking things. Take it again correctly. What is statics?
In equilibrium, say.
What is statics? Describe statics. Adasa, go ahead.
Statics is the study of forces in equilibrium.
Correct. Statics is the study of forces in equilibrium. Thank you. Well, I want to encourage all of you. The last time we had our class here, all of you refused to study your lesson notes. You didn't take enough of notes, or you didn't study them. You can't remember what I taught in the classroom, and I took my time to ensure that you were properly taken through. I took my time to ensure that you were properly taken through, but unfortunately, you did not make me proud. I was expecting that you are going to give better description, but I'm not too comfortable. Anyway, we're here to learn, and learning, you're going to learn. Don't worry, I'm all here for you. I'm not a lecturer, rather I'm a teacher. I'm going to teach. I'm going to ensure that the desired change in you, desired change in you will actually be effected, and I'm going to get the best out of you. So, relax, I'm here, and you have me here. Only that I need your cooperation so that you actually learn. I need your cooperation to learn, okay? Okay, I want a sounding response from all of you. Okay, my students.
Yes, sir.
My students are just logging on. They are not participating. You want me to say I must be seeing your faces? Everybody must be on.
Yes, sir.
Everybody must be on video.
Yes.
Turn on your video, everyone. I must see your face.
Sir.
Yes, sir.
Everybody, turn on your video. I want to see you. Turn on your video. I want to see everybody. Everybody, turn on your video. If you don't turn on your video, I'll log you out. Turn on your video. I want to see everybody.
Sir, the network is really poor. We can barely hear you. It's breaking.
It's because most of you in the classroom are not really participating. You're doing something else, and that's why you don't get what I'm teaching. And I'm not happy about that.
Okay.
That's why I force all of you so that I will see what you are doing. If you are doing something else, some of you are chatting while you are sitting online with me learning. I'm not happy about that, and you know you are doing it. Am I lying?
Victor, turn on your video.
Am I lying? Some of you are doing something
Successfully on your video.
in the classroom, and I'm not comfortable with that.
It's not on.
Some of you are doing something else. Some of you are
Turn it on now.
some of you are doing something else. I want to see my students face to face. And thanks to technology. So I want to see your face. Ensure that you are learning truly. If you're not, I'm not seeing your face, I'm going to log you out. And I'm going to mark your attendance 0. Sorry, I don't take sheets. You learn my class. I want you to learn. You must learn. You pay to learn and you must learn. Yes, we have gone through what we learned last lesson, last lecture. And we also described scalars quantity. We described vector quantities. I want someone to actually give me the distinction between scalars and vectors. Give me the distinction between scalars and vectors. Cynthia, the distinction between scale. Oh, you tell you join the class? Cynthia just joined the class today, right? Is that clear? Is that chicken? Go ahead and give me the distinction between vectors. Chicken on, and with you turn on your video so that you can go and check your notes again. Chicken on, I'm an IT expert. When you turn on your video, you want to go and check your material. I know it. So don't try it with me again.
No, sir.
You're lying. Desiree, go ahead.
Yes, sir.
Desiree, you raise up your hand. Go ahead. Desiree, go ahead. Desiree, your hand. Desiree, your hand is up. Okay.
Sir, scalar quantity describes the motion without consideration, while vectors consider direction. Yes, sir.
Desiree, I don't know what happened to you today. You are not performing. I must tell you, you are not organized today. Each time you want to give responses, your responses are not in tandem with what I expected from you today. Something is not right today about you. Something is not right today about you, Desiree. That's the truth.
Sir, let me try one more time.
Okay, try. I'll give you the opportunity. Try one more time. I said, give a.
I'm sorry, sir. Let me try one more time.
Desiree, listen to me. Give a distinction between scalars and vectors.
Let me try one.
Right? This I'm waiting. Okay. Victor, go ahead and give response to that. No, just lower your hand and turn on the microphone. Victor, go ahead. Victor, go ahead. Victor, go ahead.
Scalars. I'm coming, sir.
You are coming. You want to go and check something? Chicken, go ahead. Chicken, Victor, turn on your microphone. Turn off your microphone, Victor. Turn it off. Go ahead.
Okay, sir. Scalar. Okay. Scalar is a quantity with only magnitude.
I said.
Then vector is a quantity with both magnitude.
Now listen to my question again. Let me educate you. You are going to write an international exam. You will write an international exam, and you must be prepared from now that you are going to write an international exam, and you are better than most of these students, only that you are not concentrating. You are doing something else. Now listen to me. I asked a question. I said, give a distinction between scalars and vectors. Listen to that question again. Give a distinction between scalars and vectors. Now, Chikeno, answer my question.
Okay, scalars are quantities with only magnitude or size.
No.
And they have no direction.
That response is not good enough. That response cannot give you 5 points out of 5. The entire 5 points. No. I said, give a distinction between scalars and vectors. If you answer it correctly, I'll be glad. Go ahead. Who is answering the question correctly? Adasa, Desiree.
Yes, sir.
Go ahead, answer the question.
Scalars. Okay, scalars has no direction, while vectors has a direction. Magnitude.
You are getting it, but put it better in better perspective.
Okay, scalars are quantities with direction, while vectors are physical quantities with no directions.
Say it again, Adasa. Adasa again. Adasa again.
Scalar quantities. Okay, scalar quantities are physical quantities with no direction, while vectors are quantities with directions.
It's better, you get it correctly. That's correct. That's correct. When I ask you to take out a decision, mute yourself. Mute. When I ask you to give a distinction between scalars and the vectors, all I expected you to say is scalars have no direction, while vectors have directions. That is the distinction between the two. That is the decision. That was Victor, mute yourself. Victor, mute yourself. What is the rate of change of velocity? What is the rate of change of velocity? Desiree, what is the rate of change of velocity?
Yes, it's distance over change in time. Change in distance over change in time.
And what do we call that? What do you call that?
That is, sir? Sorry, I didn't get you.
That's what? That is what?
Is an expression that's like SI unit,
Acceleration.
the SI unit of velocity. That's
Hello, that is acceleration. Rate of change of velocity is acceleration. I'm looking for that. It's written down. Rate of change of velocity is acceleration. Rate of change of velocity is rate of change of displacement is what? It's
yeah,
rate
yes.
of change
Yes, sir.
velocity is acceleration. Rate of change of displacement. Rate of change of displacement is what? Chicken on. Rate of change of displacement is what? Okay. Zoom user.
So what did you say?
Zoom user.
Rate of change of displacement.
Go ahead. I saw your hands up. Zoom user. You didn't put your name there. I only saw Zoom user. Okay. Christabel.
Sir.
Christabel.
Velocity, sir.
What is the rate of change of displacement?
Velocity.
Oh, you are correct. Velocity. Very correct. You are correct. Velocity. How do we describe velocity? Velocity is equal to change in distance over change in time. Change in displacement, change in displacement all over change in time. Change in displacement all over change in time. That's velocity. And we did all that. And once again to describe position vector. We also describe position vector. We also describe position vector. And I gave you an assignment. We describe position vector. If you remember, position vector R, okay, which is equal to X I plus Y I plus Z K. That's the position vector, which I gave you that time. That position vector, and I gave an assignment on this position vector. I told you that you can turn away the video. You can turn on the video because of the data. You can turn on the video because of the data. You can turn on the video because of the data. You can turn on the video because of the data. Turn it off. Good, thank you. So, and I told you last lesson that position vector is very important, and it gave us opportunity to locate particles in the space. Okay, Desiree, you raising your hands. Desiree, you raising your hand.
Sir. Yes, sir. It's a mistake.
Okay, that's all right. So, and I give you that assignment, and I said that go and think about the problem ravaging the nation, the country, that you can use the concepts of position vector to demystify, to solve. I give you that assignment that you can think about it. That you see, it's when you have challenges, it brings to you how you can solve problems. And I said, let us solve our problem using concepts from this general physics. But that's no problem. Let's look at velocity and acceleration vectors. When you combine, when you make it, let's look at this. I want you to note this, please. Velocity and acceleration vector. Look at this. I want you to look at something. Velocity is having direction. You know that velocity has a direction because it's a factor of displacement. Is equal to d, nice, position vector, is pen. Okay, all over dt, change in time. That is a position, that is a vector. Let's now go for acceleration. No, I'm going to write it correctly so that you don't write nonsense. Better. Which is equal to change in velocity, all over change in time. Now, I want all of you to consider these two expressions. Very important. And I'll tell you why they are important. This we refer to as velocity and acceleration vectors. We refer to this as velocity and acceleration vectors. We call them velocity and acceleration vectors. If you look at that of velocity, you will see that the position vector r is taken care of there. Let me pick another color so that you'll be able to see it. Look at this. If you look at acceleration, you will see that the velocity vector is taken care of there. Look at it here. Now, all you need to do is to count anything. You just must know that it is the velocity vector that gives rise to acceleration vector. Just like the equation we have considered earlier, where we are describing velocity, where we are describing acceleration. Let's now look at equations of motion. Let's now look at equations of motion. Let's look at equations of motion now. Let's look at equations of motion. I've gotten your details now. I'm going to create a WhatsApp group where I'm going to send you all my lecture notes. Is that good by you?
Yes, sir.
Very
Yes,
good,
sir.
sir.
Yes, sir. Very good.
I must not see memes on that group. Minute you post memes,
Okay, sir.
minute you post any memes, I send you out. I eject you. Anyway, I will not even make you to be able to post anything there. So
We will
let's
not post any meme.
okay, then I'll make it free. I'm counting on your words. Let's now discuss equations of motion. Let's discuss equations of motion. Let's discuss equations of motion. I want to discuss equations of motion. Let's discuss equations of motion. These equations of motion, you have learned them even when you were learning integrated science. Yes, but you might have forgotten. Let's remind ourselves about these equations of motion. You want to describe velocity. Let's describe velocity. Velocity, let's describe velocity. Velocity. Let's get velocity, which is v is equal to u plus 80. Look at that specific equation 1. V is equal to U plus 80. V is equal to U plus 80. But there are things we must learn here. That our V here in this case, V is the final velocity. Final velocity. Final velocity. While U is the initial velocity. U is the initial velocity. U is the initial velocity. A is the acceleration. A is the acceleration. A is the acceleration. And what do we have? T is not there. T is what? T is time. T is time. So from this equation here, I have described all the components of that equation. I told you we are dealing with equations of motion. The first one I brought up is V is equal to U plus 80. V is equal to U plus 80. Should I throw a question open now? Let me throw a question open. Can anybody, any one of you, can you make T the subject of the formulae from this equation? Can you make T the subject of the formulae from this equation? Can you make T the subject of the formulae? If you can make it, you can do it. Let me see hands up, please. Let me see hands up if you can do it. Hello, can you do it? Adasa, Desiree, Jackson, success. From this equation, V is equal to U plus 80. Can you make T that would describe now as time? Can you make the subject of the formulae? Can you? Let somebody answer me. If no, say no. If you can't, say yes.
No, sir.
No, okay. Who again say no? Adasa,
No, sir.
that's all right.
I know we are dividing, but I don't know what to divide with.
What to do? Mute yourself. Mute yourself.
And we are dividing.
Now, let's do something. I'm going to show you. I'm going to show to you. Let me now do it now. Just say, look at it. You collect light time.
Sir,
Who's talking?
Manuela, sir.
Bekis. Who is talking?
This is
Okay, go ahead.
C equals to V minus U all over A.
Say it again.
C equals to U, V minus U all over A.
Okay. I asked you to answer a question that can you do it? You said you didn't answer me. Now you are bringing the solution that you thought is correct. Well, let's do it. Let the whole class enjoy how to get it done. So from here, what you're going to do here is to allow only 80 to stay on this side. So you do, this one will become V, this becomes V minus U is equal to 80. Now, we are going to divide both sides. Divide both sides by A. To divide both sides by A, what are you going to get? To divide both sides by A, what are you going to get? So you just say V minus U divided by A is equal to AT divided by A. The right hand side will become, this A will go for this A, so the equation becomes V minus U all over A is equal to T. And this can be written again as something else. This can be written again. This can be written again as T is equal to V all over A minus U all over A. Though this is not common, the best that will happen is that we should write it as T is equal to V minus U all over A. Bakers.
Sir,
Is this correct with what you mentioned the other time?
yes,
Answer. Let your mates hear your voice.
yes, sir,
You tandem with what you mentioned.
yes,
So at any
yes,
point,
sir.
at any point in time, from the very important equation, there are three very important equations of motion. We have brought out one of them. We have brought out one of them, and we're going to describe others now. Okay? Can I clean the whiteboard now? Can I clean the whiteboard? Can I clean the whiteboard?
Yes.
Okay, thank you. I'm going to consider the second equation of motion now. I'm going to consider the second equation of motion. Let's consider the second equation of motion, which is S is equal to ut plus half AT squared. Very clear. I'm happy I wrote this clearly. Are you with me? Are you with me? As I described earlier, S
Yes, sir.
S, let me describe that one. S, I think let me blue. S is the displacement, displacements. T is what? Time. T is time. U is initial, that's U is initial velocity. U is initial velocity. While V is final velocity. Final velocity. Are you with me? From there, we see okay, A is acceleration. Acceleration. What is missing that I'm going to describe? Nothing again. We have all of them. We have described 1, 2, 3, 4, 5. I've described all of them. So from here now, from this equation, S is equal to ut plus half at squared. That's the second equation of motion. And the third equation of motion is also very clear. Let me write the third equation of motion. Let me see color that will be distinct. Third equation of motion, it says v squared is equal to u squared vs plus 2as. 2as. Now, this same factors are also responsible. U here is also the initial velocity, A here is acceleration, S here is displacement, and the V is the final velocity. Let's describe this. When an object is in motion, there is an initial velocity before a force acts on that object for it to cause motion. There's a record of initial velocity. And when the object starts to move, there is another velocity. But when it gets to the point at which you want to take your measurement in terms of motion, you will take final velocity. And from point A to point B, what is the time that was used for that movement, for that motion to be achieved? That is time. For acceleration, which we described earlier as the rate of change of velocity. What was the rate of change of velocity from distance A, from point A to point B? Rate of change of velocity. So when you know the rate of change of velocity, you will not know. And the displacement now becomes the distance, though a distance, the direction is the displacement. So it's done. What you must learn now is that these three equations must be part of U. V is equal to U plus AT. S is equal to UT plus half AT squared. And V squared is equal to U squared plus 2AS. They will be part of U. They will be part of U. Any question on this, please? Any question from anyone? Any question, please? Hello? Must we run away?
No, sir.
Okay, any question? Just said no. Any question? Cynthia, Christabel. Any question?
Sorry,
No,
said,
sir.
the last few words you
Last what?
said was bad.
Cynthia, you saying something? I'm on yes. Cynthia,
Sir,
you said something. I can't get you clearly.
I did not say anything.
Okay, Desiree was talking. Desiree was talking.
Yes, sir.
Yeah, go ahead.
So I said the last few words you said after you gave us the third equation. I didn't quite hear you because actually my network broke down, which is a word like that, and I couldn't connect.
I'm going to take
It
that.
actually disconnected before you were done with the third equation.
I'm going to take that again so that everybody will get it.
Okay, so thank you.
God bless you. Welcome, my dear. Now, when you are talking about equations of motion, there are three. And I've listed the three, and they are written on our whiteboard here, which you all have access to. Now, the first one is V is equal to U plus AT. The second one is S is equal to U.
I meant the explanation after the equation.
After the equation, okay? And I told you that all of them, we have described each of the components of this equation, that S is the displacement, T is the time, U is the initial velocity, V is the final velocity, and A is acceleration. And I said that that displacement is only measured in a particular direction, moving from a point A to point B. That's the displacement. Yeah, displacement is a distance, but with a direction. Why you now want to take the velocity, the initial velocity, every object at that point of starting a movement, that object has an initial velocity. And when you now stop the object from moving, and you now want to know what happened in that time space, there's what we call final velocity. And I said between point A and point B that you want to take a displacement, a distance in a direction, there is acceleration, which is a change in velocity. So you see that they are interwoven. Acceleration is a change in velocity, while the initial velocity is the velocity of that object at the point of starting a displacement, while final velocity is the velocity of that object having completed that movement or displacement. Can you now get it clear now? Is it clear now? Is it clear now? Is it clear now? Okay, let me move on. Let's now go to dynamics. We are going to consider Newton's law of motion. We are going to be considering Newton's laws of motion. We are going to be considering Newton's laws of motion. We are going to be considering Newton's laws of motion. So we are through with equations of motion. Now we want to consider Newton's laws of motion. Newton's laws of motion. Newton's laws of motion. Newton's laws of motion. Now, we shall be considering Newton's laws of motion. Oh, let me use a clearer color. Let me use a clearer color that can write better. Newton's laws of motion. Newton's laws of motion. Newton's laws of motion. Yes, for classical mechanics, there are laws binding operations in classical mechanics. There are laws binding operations in classical mechanics. And these laws, one of the promulgators happens to be a great scientist, a great physicist, who is Isaac Newton. Isaac Newton promulgated some laws of motion. And the first law of motion that Isaac Newton promulgated was called law of inertia. Law of inertia. Isaac Newton, a great scientist, a great physicist, actually promulgated 3 laws of motion. And the first law of motion that Isaac Newton promulgated was law of inertia. Law of inertia, which is also known as the first law of motion. Law of inertia is also known as the first law of motion. So let us now describe the first law of motion, which is also known as the law of inertia. Law of inertia. Law of inertia. Law of inertia. Not in the classroom. Law of inertia. Law of inertia. Yes. That law of inertia is the first law of motion, and it goes this way. The law of inertia states that an object, any object at all, remains at rest. Any object or an object or any object at all remains at rest or in a uniform motion unless acted upon by a net external force. Let me take it again. The first law of motion, which is also known as the law of inertia, states that an object remains at rest. An object remains at rest or in a uniform motion unless acted upon by an external force. Unless acted upon by an external force. First law of motion states that an object or any object at all remains at rest or in a uniform motion unless acted upon by an external force. I will explain. Now, I want all of you to be looking at me and look at, you have to concentrate and you have to tell me if you are seeing my hand. Are you seeing my hand? I want you to respond, please. Are you seeing my hand?
Yes, sir.
Good. I don't know why you are seeing this. Can you see an object on this white board? Can you see it? Can you see it? Nobody's answering me. Can you see this?
Yes.
Yes, sir. Yes,
I
sir.
can't see anything, sir.
You can't see this object.
It's not just us. Someone just complained that they can't hear.
Adasa, mute yourself. Adasa, mute yourself. Who is changing my whiteboard? Who among you is changing my whiteboard? Who is changing my whiteboard? Now, if you look at these objects, I'm holding my hand. There is a small, tiny object on it. This object you are seeing here that I'm pointing to will not leave this position until decided upon by an external force. So let's now agree that an external force is now acting on it. Look at it. And it's changing and it's moving. I have demonstrated to you that an external force is moving on this object, is acting on this object before it can move to a new location. In this case, that's the first law of motion. The first law of motion, which is also known as the law of inertia, states that an object remains at rest at one position without changing until an external force acts on it. So that is the first law of motion. Let's go to the second law of motion. Second law of motion as promulgated by Isaac Newton. As promulgated by Isaac Newton. So we go for second law of motion. The second law of motion states that the force acting on an object is equal to the mass of the object times its acceleration. The second law of motion states that the force acting on an object is equal to the mass of the object times its acceleration. Let me take that again for those of you that want to write it. The force acting on an object is equal to the mass of the object times its acceleration. Let me now give you the formula for the second law of motion, which is this, which is the force, which is equal to m, that is the mass, and acceleration. Are you with me? Mass and acceleration. Don't forget, acceleration to as direction is a vector quantity. Force is a vector quantity, so also acceleration is a vector quantity. Now, this equation here that you are seeing actually describes the second law of motion. That equation describes the second law of motion. We say that the force acting on an object is equal to the mass of the object times its acceleration. Now, let's look at the third law of motion. 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 The third law of motion. Third law of motion. The third law of motion. What does it say? For every action, there's an equal and opposite reaction. For every action, there's an equal and opposite reaction. Say that again. For every action, there's an equal and opposite reaction. I wish you have a laboratory so that I can demonstrate that to us in the laboratory. And that gives rise to collision and so. Don't worry, I'm going to give you details of that. I'm going to do a simulation where I'm going to see that. Even if there's no laboratory, I'm going to do a simulation where I'm going to see that third law of motion being described in an experiment, in a collision experiment, where two objects come in like this. You just two objects will come like this and they will collide. And you now see that truly for every action, there's an equal and opposite reaction. I'm going to demonstrate that with a simulation. Just take it easy. So I've described the three laws of motion as promulgated by Isaac Newton. I have described the three laws of motion as promulgated by Isaac Newton. First, I gave you the three equations of motion. V is equal to U plus AT, S is equal to UT plus R, AT squared, and V squared is equal to U squared plus 2AS. That is the three equations of motion. And I also gave you Isaac Newton's laws of motion. The first law states, which is also known as the law of inertia. Law of inertia. I-N-E-R-T-I-A. Law of inertia. An object remains at rest or in uniform motion unless it is acted upon by an external force. That is the first law of motion. Second law of motion says that the force acting on an object is equal to the mass of the object times its acceleration. And the third law of motion says that for every action, there is an equal and opposite reaction. So every action, there is an equal and opposite reaction. Questions, please. I want your questions, please. Questions? Questions, please. Questions, please. Questions, please. Questions, please. My students are not asking questions. Questions, please. Where is Victor? Victor ran away. Victor don't participate in this class. You will not get my attendance, so I'll mark you 0. You have not been consistent in the class. You have not been consistent in the class. Any question from any one of you? Any question?
Sir, Victor's network is having issues. Network.
You said what? Success?
No, I said Victor's network is having issues. He's disconnecting.
Are you with Victor that you know that? Are you with him that you know that? I will not mark him present, I will mark him absent. He was never consistent in class. I'll mark him absent until he changes his way and is with us in the classroom.
Sir, we're actually all in class and we're having issues with the network. No, sir, we're actually in the same class. We're all having network issues. That's why we go out and in of the meeting.
Okay. Now, if you don't have a question for me, I have a question for you. All of you, put on your videos. All of you, put on your videos. All of you, put on your videos. Everybody, put on your videos. Everybody, your videos. Cynthia, your video. Now, I want the volunteer to state one of the equations of motion. State one of the equations of motion. Any volunteer, state one equation of motion.
Okay, sir. The first equation of motion is V equals U plus 80.
V is equal to U plus 80. That's correct. Another person, Desiree, yes, go ahead. Desiree, raise up your hand.
Sir, the second equation is S equals to UT plus half 80 squared.
Okay, that's correct. Now the equation of motion, we're going to give us that one. Adasa.
V square equals to
Adasa. Adasa.
Yes, sir. Yes, sir. B square equals to U square plus 2AS.
Yes. What is the Adasa? What is U?
Yes, sir.
What is U in that? What is U in that?
Sorry? Initial velocity, sir.
Correct. God bless you. Sir. In that third equation of motion, Christabel, what is S? In the equation of motion, equations of motion, what is S? Christabel.
The S is displacement.
God bless you, you are correct. I'm happy. Beckes. Beckes. What is A?
acceleration.
Correct. That's good. Well done. Now, I want Desiree to describe the law of inertia. State the law of inertia. Desiree, state the law of inertia. I'm waiting for Desiree. State law of inertia.
The law of inertia states that an object remains at rest or is in a uniform motion that's acted upon.
That's what. That's a word missing there. State it again, Desiree.
I said the law of it actually states that an object remains at rest
Yes.
or is in a uniform position
Yes.
unless acted upon by an external force.
Or uniform motion. You are writing nonsense. Uniform motion.
Sir?
Who's going to do it better? I'm going to do it better.
Uniform motion.
Huh? Continue. Emmanuel Adasa, go ahead.
Okay, law of inertia says that an object remains at rest or in a uniform motion except being acted upon by an external force.
That's correct. Unless being acted upon by external force. That's correct. Now, second law of motion. Zoom user. Second law of motion. Second law of motion. Zoom user. That is the name I'm seeing. I'm seeing Zoom user. If your name is Zoom user, answer my question. Who is Zoom user? Zoom user. This is Zoom user.
My Zoom the piece.
Who is speaking Zoom user there? Can't you put your name?
But why is he doing like that?
Zoom user run away. Okay. Big case. Second law of motion.
Sir,
Second law of motion.
Says that the force acting on an object is equal to the mass of the object times acceleration.
That's correct. Third law of motion, success. Third law of motion, success. Israel is not here. Jassy, third law of motion. Jassy, third law of motion.
Sir, the third law of motion.
No. Jassy. 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 Jassy ran away.
Yes, sir.
Third
Yes,
law.
sir.
Your video, I will see your face.
Sir,
I'm listening. Cynthia.
my video is on, sir.
Didn't say anything. Cynthia, go ahead.
Sir?
Third law of motion.
The third law of motion
Third law of
is
motion.
for
Cynthia.
every action with an opposite.
I'm talking to Cynthia. You didn't say anything at the right time. Cynthia, third law of motion. And your face.
Okay, sir.
Video. I will see your video.
Yes, sir.
I must see your video, Cynthia.
Sir.
I'm not seeing your video. You can answer my question. I must see your video before you can answer my question. Yes, go ahead and answer my question. Turn off motion, Cynthia. Cynthia,
Sir.
you can't answer my question again. I can't see your video. You can't answer my question. Victor, motion, Victor.
Sir.
Cynthia, you can answer again because you have missed the chance. Victor. Victor.
Yes, sir. Yes, sir.
Your video first.
Hello, sir.
Your video. I must see your face. I must see your face. Then, my question now. Third law of motion.
Hello.
Third law of motion. Okay, that's all right.
Right.
Everybody mute yourself. Since you are not answering my question, I'm moving on. but I'm recording your class responses against you. When your class responses are bad, you're going to have very poor marks. When your class response is bad, I'm going to score you low on your class response. I'm going to score you very low on your class response. When I ask a question, you run away, you can't show your video. Do you want me to say that you are copying somewhere or you're reading from somewhere? Then I score you low. Now, types of forces. I want to discuss types of forces now. Types of forces. I want to discuss types of forces now. Types of forces. I want to describe types of forces. They say, do you have a question? They say, do you have a question? Okay, that's right. Types of forces now. The first one I want to consider is gravitational force. Is gravitational force. Number one, gravitational force. Gravitational force. We want to describe gravitational force. Gravitational force is an attraction between two masses. 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 And it is so represented as follows. F is equal to G mass 1 mass 2 all over R squared. See what I've written. This can also be written as F is equal to G into brackets M1 M2 all over R squared. So these two equations are the same. These two equations are the same. These two equations are the same. And gravitational force, as described to you, is an attraction between two masses. Gravitational force is an attraction between two masses. And it is represented as follows. The force is equal to G into M1, M2 all over R squared. M1, M2 all over R squared. That is the way it is described. Another force that we're going to be considering, is normal force. Normal force. Let's look at the second force, which we refer to as normal force. Normal force. Normal force. As pronounced, normal force. Let me write it for you. Normal force. Number 2. is called normal force. Normal force. That normal force, how is it described? Normal force is perpendicular contact. Normal force is the perpendicular contact force exerted by a surface. Normal force is the perpendicular contact force exerted by a surface. Look at this surface, everybody. Look at this. Look at this surface. Everybody look at this surface. Look at this. Look at this. Look at this surface. Everybody look at this surface. A normal force is a perpendicular contact force exerted by a surface. A normal force is a perpendicular contact force exerted by a surface. A normal force is a perpendicular contact force exerted by a surface. A normal force is a perpendicular contact force exerted by a surface. Let's go to the next one, which is called frictional force. The third one 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 is called frictional force. Number 3 is called frictional force. It's called frictional force. The third one is called frictional force. And frictional force opposes relative motion between surfaces. Frictional force opposes relative motion between surfaces. Look at this. There's a friction between these two surfaces. There's a friction. That's called frictional force. Frictional force opposes relative motion between surfaces. We also have tension force. We also have number 4. We also have tension force. We also have tension force. Tension force. We also have tension force. That tension force is a force, is pulling force transmitted through a string or a rope. A tension force is the pulling force transmitted through a string or a rope. When you are doing this play, we normally do. We pull a rope at the middle, and at both ends, the two things will be pulling the rope. That's what's called tension force. And there's a spring force. That's also called spring. The fifth one is called spring force. The fifth one is called spring force. Which one is called spring force? This spring force is also known as the Hooke's law. The spring force is also known as the Hooke's law. We're going to get there. We're going to describe what Hooke's law is all about. We're going to describe what Hooke's law is all about. I have listed 5 types of forces. I have listed 5 types of forces. The first one I mentioned was gravitational force. The second one I mentioned was normal force. The third one was frictional force. The fourth one was tension force. And the fifth one is spring force. The first one that I mentioned, which was gravitational force, I described it to you as an attraction force between two masses. I described it to you as attraction force between two masses. And I gave you formula as F is equal to G into M1, M2 all over R squared. The normal force, I also describe it as the perpendicular contact force exerted by a surface. I also mentioned frictional force, which opposes relative motion between surfaces. As well described tension force as pulling force transmitted through a string or a rope. And it's also mentioned to you spring force. And that spring force was the one also described as the Hooke's law. The Hooke's law. I want to know how Hooke's is being squared is when I mention Hooke's law. Hooke's is like this. Hooke's law. Spring force is also known as the Hooke's law. Spring force is also known as the Hooke's law. Spring force is also known as the Hooke's law. Thank you. God bless you. Today, I'll give a synopsis of what you have learned today. I'll give a synopsis of what you have learned today. Today, you have learned the equations of motion. We have learned equations of motion for one-dimensional motion. We have learned all the three equations of motion, which I mentioned to you. V is equal to U plus AT, S is equal to UT plus R AT squared. I've also mentioned V squared is equal to U squared plus 2AS. And I gave every component of those equations as U as the initial velocity, V as the final velocity, A as the acceleration, S as the displacement, T as time. We went further to describe the Newton's laws of motion. I told you that Isaac Newton, a great scientist and a physicist, promulgated 3 laws of motion. And the first one he promulgated, which we call the first law of motion, which is also known as the law of inertia. It's also known as the law of inertia, states that an object remains at rest or in uniform motion until it is acted upon by an external force. Second law of motion states, as promulgated by Isaac Newton, states that the force acting on an object is equal to the mass of that object times its acceleration. And I also went ahead to give the third law of motion, which states that for every action, there is an equal and opposite reaction. For every action, there is an equal and opposite reaction. I went further to give types of forces. I went further to give types of forces. And what are types of forces that we have? We have gravitational force, which I mentioned earlier. We have normal force. We have frictional force. We have tension force. We have spring force. I told you that the spring force is also known as the Hooke's law. It's also known as the Hooke's law. So that is the end of the class.